show you how you can mold with some plastiline-like mass areas that you would never be able to scan with a normal optical 3D scanner. Not every one of us has the possibility to use a CT scanner to scan inside geometries, and who of you ever asked for service knows that the price is quite elevated. This workaround will help you to be able to cope with these situations, and the loss of preciseness is in most of the cases quite acceptable, because in many cases there will be a sand cast or any metal cast parts will be the object of that study and the scan, and the preciseness of the production methods in itself are not very good. Lucas will show you right now with an KTM cylinder head how this could be done. I really strongly recommend not to use any kind of dishes or other things that you use to prepare food, and if so, please don't use them ever again for preparing food. This video is just let's say a show how we do it. It's not a recommendation to do it the same way. Hello, today I am going to do an cast with Vinamold red. The consistency is a bit like plastiline mass, and the surface is a bit greasy. And you will feel that on the fingers as well. You will need your cylinder head, of course. I have a heating with a pot. I have a heat gun, 2 screws that I will later on use to extract the mass out of the cylinder. I have a 1PT100 thermal element, and very first I will try to bring the cylinder head in the best position for filling it up. Therefore I made some device that I can adjust the angle, and with the cylinder head screws I fixed that cylinder head on that plate. I will loosen the screws to adjust the angle. I will just bring it in some horizontal position. So right now it looks quite promising. I think I'm nearly horizontal. I will double check as well the perpendicular angle. That's fine. It's indicated to spray some kind of the oil on the walls of the metal to get the extraction of the material a little bit easier. It can be mineral oil, or it can be some normal oil that you use for cooking as well. It will be lubricated right now in all the areas fine. Next is heating up the pot, and I'm going to heat up the Vinamold. I'm going to cut it into smaller pieces that will make the melting time shorter, and I will have not to wait for so long till everything will be liquefied. After the masses melt, it's a temperature of at least 160 degrees Celsius. The indication from the fabricator is in between 150 and 170, so it's exactly the middle. It's taken about 10 minutes to melt the mass. Meanwhile, I used some kind of thin metal to bend some fixations to be able to keep them in place while I'm filling up the channel. So I'm using some special spoon to fill it up. The cylinder head I was heating up with the heat gun to have a longer time for the material to flow inside the small details of the geometry. If you don't heat up the cylinder head, it can happen that the material will cool down too early and you will not have a very good filling inside the geometry. It can lead to some areas where you have air trapped in the geometry. After 8 hours of cooling down, what is recommended, it can happen that you will have to fill up again a little bit material because of the shrinkage. You will not have any kind of the problems in correcting something because the material is very easy to handle. It is as well peeling off air very easy from the devices. In most of the times you have to fill up a little bit of material, but it will be in the first 10 minutes. After the first 10 minutes, shrinkage wasn't very strong. I'm right now going to take out the valves from the cylinder head. I have good access in this device to get them out and dismount the springs. I just removed the springs. Right now I'm going to try to push through the valves. I'm going to do that slowly, but it's really coming out very easily. I think this is because of the oily surface of the material. The right side looks fine, no adhesion on the material of the valve. So right now I'm going to try to drag out the casted core. I'm just first removing my fixation for the screws, and the screws, because of the thread, are giving me the possibility to drag out the whole core. But it's moving already. With pliers I was able to drag that core out. There was some very small cracks inside the material, but nothing really problematic. I was just cutting it a little bit to get off my surface that I had because of the casting, and later on I will fill up the holes with a small amount of Vinamold. Here I had some bigger cracks, and I used a little bit of glue to glue them there, but of course you can just heat them up or use a hot tool, some piece of sheet metal or so to glue it. Here you can see the marks from the cast inside the channel, but the surface is very smooth, and it seemed to have a very good representation of the surface of the cast. Right now I'm going to try to fill up the thread holes, and therefore I'm going to just heat a small amount with the heat gun of the material to fill it up. It was very fast getting liquid, and as it is a small mass of liquid, it is not really a big problem to get it liquefied. I'm filling up the holes right now. With the knife I will try to cut a smooth surface on the end of my core. I will try to cut it easier with a heated up knife and to get a better surface because of that. You can see here like some mass of the liquid is disappearing because of shrinkage, but as I have a little bit of excess material, I can just push it in and fill it up again. In this temperature range, the material is not a liquid consistency, it's more plastiline, like you can just shape it. Anyway, I'm going to fill up a little bit more material. I think there is just a little need to get these holes filled up evenly. Well, right now it looks a lot better. Instead of cutting it off, I'm going to just grind it down with the hot cutter knife. With the same principle, you can as well close small crack holes or extraction damages that you cause. Just be sure that you don't create a shape that is too far out of the original one. So right now you see in how you can cast a core, and right now you're going to see how to scan it with the laser scanner. I just sprayed a little bit the surface of the core because it's glossy. Of course, with the laser scanner you could do it without spraying, but the real life shows that you get a better surface quality if you just spray it anyway. What is very important is that you create some suitable fixations for the scanning, because the material is elastic and it will be deforming through its own weight if you are not storing it the right way during the scanning process. We are using here some special fixation that are made with thread bars, and we are measuring in the position before scanning some reference edges between the channels to be sure that they have the right distance to each other, because we can see here that there is some probability of not positioning right them to each other, and if so, you will have an easy time to, let's say, afterwards integrate it in the scan that you did out of the outside geometry from the motor itself. Of course, you don't have to use thread bars. You can use as well thick needles, whatever is easier for you. What is the big advantage of threads is that you can easily adjust the height of each position, and it makes it easier to get the right position in horizontal and vertical areas. What is important is that you don't cut the thread bars too short. It's very important that you are able to scan the downside as well without repositioning that cores that you casted, as they are, let's say, not very stiff. You are risking that you will get a second geometry in the second position, and it will deform differently and afterwards not merge to one volume in a fine way, or not merge at all. It can as well have an error influence on your result. So if you are just doing it like we are showing here, and you are sticking some markers on the thread bars, you will have an easy life scanning it as well from the downside. You can just close that very small areas that you create as open mesh with standard tools, and you will be just fine with the result. In this situation, we will need some step model for making the simulation. What is a very easy job with the red bundle Geometric Essentials, you as well are able to create reference surfaces, axes and other things for positioning the scan result in the right way inside your simulation. Of course, you have to do it for the inlet and outlet core that you created, and afterwards you are without any problem able to import it into GT Power in the simulation software. Of course, you can just use it for make cross-section analysis in some CAD software, whatever you want, or do some heat simulation, any kind of CFD simulation that you want to do. These are things that you would in other cases not be able to do with a normal optical 3D scanner. You will get a bunch of new degrees of freedoms of tasks that you will be able to infront with your 3D scanner, and you will find the material that you maybe need for doing this job in the show notes below. And of course, if you are just doing it from time to time, you can borrow a scanner and get the material as well. You just find the links below in the show notes, and that's all for today. I think this is enough content for one video. Simulation is a bit too big content for this video, and we see you next time.